Well, hello, Honors Algebra 2. I've missed you guys. I hope you've been having some fun in your forced vacation from school, but I miss you. And hopefully this distance learning will not last real long and you'll be back in the classroom and we can get back to things as we have experienced them all year. But we are going on from our test to the next chapter, and this next chapter is triangle trigonometry, which is chapter 12. We're going to start out with some very basic ideas because I don't know what you've had in Algebra 1. You may have had some of this, you may have had none of it. Most Algebra 1 teachers don't deal with it because they think Algebra 2 will cover it, so they leave all of it for us to teach. So I'm going to assume that, and so I'm going to go through a lot of basics here. For some of you, this will be, oh, I already know that stuff. Well, stay tuned. We'll get to stuff that will be more challenging. Right now, I want to talk to you about the Cartesian coordinate system. The Cartesian system, 0 degrees here, and we go around this way, which is counterclockwise. So that's why these quadrants, which are divided into 90-degree elements, are labeled the way they are. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So over here I have an example. By the way, you need to know this, so put that in memory. We're going to take an angle that I'm going to call theta. Now you will see a lot of angles referred to in trigonometry that use Greek letters. Theta is the most popular, but you'll see beta, and you'll see gamma. So those are the three we will use most often. This is spelled T-H-E-T-A. Here I put theta in there to show you I'm on this side of these lines. That's what I'm measuring. Now this line right here, I'm going to label as the initial side. And over here, I'm going to use a terrible word. It's not a word I like. It's called the terminal side. And I don't like it when airlines end up their flight at the terminal. Because when you say a patient is terminal in the hospital, it means something bad. And I don't want this to be bad in your head, okay? It means the end. So we're going to start and end here. Now if you were to look at this and compare it to this, does it fit here? Would you say this angle theta is in quadrant 1? Or is it bigger than that? I would say it's bigger. Quadrant 1 would mean I have a 90-degree angle here, and so I've already gone past that. Well, it doesn't seem to be in quadrant 2 because here would be the extension to 180 degrees of quadrant 2. So I've already passed through these guys. And I know it's not down here in quadrant 4 because I haven't gone that far. So it must be quadrant 3. Now, quadrant 3 ends down here at 270 degrees. So this is closer to 270 than it is to 180. So it might actually be something like 230 degrees, maybe a little less. But that's the size angle I have for theta. And so since I'm guessing at this angle size, I'll say it's approximately 230 degrees. Well, that sort of gives you an idea of how we use this. Now I want to illustrate how you will do some work in your homework. First of all, you're going to be identifying where these angles would be. So if I put here 225 degrees, would you identify that as here, 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 or here? Well, you know it's less than that, and it's more than that, so it has to be quadrant 3. So your answer simply would be to write in the answer, quadrant 3. You don't even have to put Q in front of it. I know what you mean. Now suppose I did 335. Where would you say that guy is? Well, it's not one of these because it's more than 270, so it has to be over here. We would say quadrant 4. But wait a minute. What if I add a whole circle to this 230 and told you instead of stopping here, we went around this circle one more time and added another circle to it, and our total turned out to be 590. Would you recognize that? Well, that's really big because it's more than a normal Cartesian circle. So how much more? Well, the way you solve it is to subtract out circles 360 at a time and come back to those numbers that are less than 360, and that tells you where you are. Well, we already said 230 was down here, so I would enter this as my answer, even though the angle was way bigger than a circle. All right, now I want to introduce you to one other direction, and I'm going to come way over here to do that. In our circle, we agree to go counterclockwise. But if I don't do that, if I go the other direction clockwise, suppose I came this way, I have a special way of showing you that. This would be a minus sign in front of it, which means I'm going opposite the normal direction. And in this case, I could say it's 135 degrees, which puts me right about here. And I told you I'm going this way instead of the normal direction. So I'm going to identify here, whenever you see this, it means direction of travel. It does not mean this is a negative number in that sense. We're not on a number line and positive numbers are going this way and negative are going that way. That's not what we're doing. So don't confuse the two. This simply means I've started here, normal position, but I've gone clockwise in my rotation. So when you see numbers in the homework that have a minus sign in front of them, you're going to start still at 0 degrees here, but you're going to go the other direction and try to figure out adding either 45 or 90 degrees each time, where in the world you are in the Cartesian system. I don't think that's complicated. It's just different from what you're used to thinking a minus would do. It, in trigonometry, means direction of travel. All right, I'm going to show you one other thing, and that is probably the most frustrating part about this assignment. So I'm going to move the board over here and give you an example of what I'm talking about. 63.6 degrees. Now, I'm asking you to convert this to a new system. And the new system is this. We have degrees, we have minutes, and we have seconds. Now, seconds are two little hash marks like that. This is 1 for minutes, and as you know, there's 60 minutes per hour, and there are 60 seconds per minute. So those are the units we're going to be working in. So if I have 0.6 here, I want to find out how many minutes that is. So how would I do that? Well, I know the 63 is staying the same. But what does the 0.6 become? Well, I want to divide it into minutes. And there's 60 possible. So I'm going to take this and translate it into 6/10 times the 60 minutes. Well, you can see right now, if I cancel this, I get a 6 here. So 6 times 6 gives me 36 minutes. That's all there is to it. I don't have any seconds here because this number did not run out farther, and I need to find out the seconds beyond that. So my final answer would be 63 degrees, 36 minutes. Seems simple enough? I hope so. You will be given things like this in degrees and minutes and asked to convert it back to decimal like this. Well, let's take a look at that. Suppose you're given this 63, 36. Well, this is easy. Let's just go backwards and divide by 60. Well, it turns out that if you do that, you end up with 0.6. And the degree mark should go over here then. And you saw how I did that in originally finding the 36 minutes. So this is totally new for most of you, I think, because Algebra 1 has no place where it teaches it. It is part of what we teach in trigonometry because much of our world deals with topographical maps where these will be sections of angle measure in those maps. And so if you're doing, whether you're a pilot, captain of a ship, any kind of navigation will require you to have some skill. So you have to learn it somewhere, so we teach it here. Not that all of you are going to rush to be captains on board ship. So, a couple of things that are new, a couple of things you may have heard about before in other math classes, but this first section in chapter 12 is very simple, so I wish you success with it, and I will give you more instruction when we get to section 2, which I think I will be assigning on Friday, not for you to work on over the break, but for you to work on after the break. I may list it on the assignment bulletin board.